All right, so I'm catching up on some video editing for my usual subscribers to this channel. And I thought I'd give you a little update on my solar panel project and tell you why it's not done yet. I had a very custom install in mind for this project. The bus roof is curved, and I want to preserve the lines of the bus. I don't want these panels like sticking out and, ruining the classic lines of the bus, by putting solar panels on. So I wanted a very close mount to these solar panels. I wanted them very close to the roof. And I also wanted them to be able to tilt, because if they're they're laying close to the roof and they're one side's going to be angled away from the sun, I wanted to be able to tip them up to catch the sun on the side that maybe is away, or lift them up so that they're flat when parked. Imagine the roof of the bus is curved, and one side would be like this and the other side would be like that, going down the bus lengthwise, 2 rows of panels. So I had these sunpower panels, these 250 watt sunpower panels. They're pretty popular. They were available inexpensively from Santan Solar in Arizona. I picked up a load of them when I was down there last January. But they have a rather unique extrusion on the side of these panels. So I started designing some custom mounts and 3D printing them with my 3D printers. As some of you know, I'm really into the 3D printing stuff, so I will try and utilize those whenever I can. The material I chose was ASA, this Polymaker ASA stuff. There's a box of it up there on top of that printer. It's pretty good stuff. It's UV resistant. It's kind of like, it's like ABS, but it's got UV resistant properties to it. These are some of the mounts that I designed here. So this is designed to fit into that extrusion on the side of these SunPower panels, and retain it catch it on the bottom here, and also hinge. So this would be a mount, and you could hinge it here. And this base is so large because I also wanted to use VHB tape to hold these things down. I wanted a large surface area for the VHB tape to adhere to hold the panels down. Another design criteria is that they be latched. So when they're retracted in the traveling position, that they be positively retained and held down, not just alone by a linear actuator, but there be some sort of positive latch. I didn't necessarily want to, have to get up on the roof with a ladder or something to raise them manually. So I don't know if I mentioned it before, but we're trying to design a linear actuator situation to lift these panels with. So there was a lot of sort of variables here, right? So we wanted this, close to the roof, which actually required 2 different heights. A fairly close height on the outer edge. The center of the panel had to have some clearance and clear the curvature of the roof, and it required a different height bracket on the towards the center of the bus versus the outside edge of the bus. And then this is a part of a latch mechanism. So we embarked on several weeks of design iteration on these things here, these 3D printed parts, to find some brackets that we're happy with. And then these are designed to be screwed in this way. There's a whole bunch of different ones that I made. Lots and lots of things went in the trash. There's corner brackets, center, say middle brackets, I guess you could say, for the middle center line of the bus, and then there was outer brackets, and then there was a latch. So all these sort of variables. And then we had to test this with VHB tape to see if VHB tape could do the job. And we had to test the lifting mechanism. So what I'm going to get into now is a series of videos that I shot during these phases where we were, testing the brackets, testing the lifting mechanism, and basically it was a big fail. And this is why my solar project is not done yet. In addition to other things, I spent a lot of time sort of trying to find a mounting situation that I was happy with, that would, enable me to have them close to the roof of the bus, and tilt them to capture the sun. I couldn't meet those objectives. Also got busy with work, sort of decided maybe I might hire the project out. Been talking to AM Solar about it. Even their brackets that they sell, the commercial, I think they're stainless brackets, don't fit these SunPower panels because of the thickness of these. They're just thicker than the ones that were sort of commercially available. I know I could just drill them and just do whatever, different things, but and if I wanted to just accept them not tilting, this could probably be done. But let's look at the videos. Let's have a look at what we attempted and the failures associated with that. All right, I'm over at Mike's and we're checking out this 3D printed bracket that I made. And we stuck it on a piece of bare aluminum. And it's this VHB tape under here. And we're going to just check and see how strong it is. We've been beating on this. The plastic is really super strong. This is printed out of ASA, which is a UV resistant plastic. So Mike's going to do a pull test on it here. So we're going to go ahead and, well, first of all, we know gravity is fine.
Gravity's fine. So do you want to do a sideways?
I would suggest that you sit it on the floor and stand on it and just try and pull on it. Let me get over here. So both feet centered. Nice. So you pulled really hard. You turned red.
Yeah, I did. Just
okay, so that VHB tape's only been stuck on there about an hour, and it requires 24 for a full cure. You're red.
Yeah, I am.
Okay, let me try.
Okay, I'll film you.
So we did break it. I was pulling on it, and Mike didn't get it recorded, but we're cleaning it off. It does clean off with a razor knife pretty good.
It feels like that stuff that you use on your walls.
Yeah, it's probably the same thing they use on the...
yeah, this is the same as that.
The same stuff they use
That's
on those
what this is.
Scotch things that stick to the wall.
Yeah, for a long time. It feels like it.
Interesting. All right, so we got this chunk of aluminum here, and we got VHB tape on a bracket that we're testing out here now. This has been curing for 24 hours. Yesterday, after it sat for an hour, I was able to pull it off, but now we're gonna see if this is gonna come or not. You see the panel bending up there? You see that? It's pretty strong. I'm gonna give it a really good reef here. Ow. Okay. It took some force. Came away at the plastic. I was on there pretty dang good. I don't know if you saw me bending this sheet here. I would say, what is that? Is that like not quite 1/8 inch aluminum? Obviously it adheres better to the aluminum than it does the plastic. And that may be possibly the grade of VHB tape here. This is the 4950 stuff. They do have other stuff that is maybe formulated better for plastic. I have a feeling that if this was aluminum to aluminum, that wouldn't have happened. They wouldn't have been able to pull it. All right, so this is the VHB 5952 test. And it's on ABS printed parts on a sheet of aluminum. We got Mike pulling on it here.
Oh my
You
God.
see it flexing.
Oh, that was a slight peel. But
It is coming. Yeah, and it will peel.
Oh
if you pull straight,
yeah, pull straight. It
it's
won't
pretty
come off.
hard. Well, you almost had it off of there, but I mean, you were pulling pretty hard.
Just if I go like that.
If you
and
tip
rip-
it, yeah, if you tip it, you can get it. So you're mushing it back on.
So if I mush it back on, and if you put maybe weight on it after 24 hours, still that's.
So where it will fail is if it gets a sideways force. So go ahead and give it a tip while you're doing it.
So a sideways force
It will fail. Yeah, see that? Boom. No problem.
only on the plastic side. Yeah.
Yeah, I left an imprint on the plastic there. The ABS. Actually, I think this is ASA.
Yeah, this stuff is good stuff. It comes off.
Yeah, it's removable like command tape would be.
Yeah, it's command tape, dude. This is really good command tape.
It's pretty good stuff, huh? Give it a yank. Oh, I just broke a chunk off.
You have to peel it. It's gonna pick it. Yeah. But at least it peels cleanly. So if you want to move your panel or paint your bus or redesign, okay. And so this was what? 2 square inches of it? 1, 2, yeah.
Yeah. All right, we're getting ready to test out this hinge mechanism. 3D printed hinges for SunPower panels with a lifting mechanism so that the panels tilt.
It's upside down right now.
Yeah, the panel's sitting upside down. We've got everything mounted and we're about ready to test it.
Yeah.
All right, so I'm going to guide this. We'll see it comes off here.
All right, ready?
Yep.
We should probably use the dead battery first, but.
Just give it a little pulse.
I am, there's nothing happening.
Okay, you got to switch the polarity then.
Okay, yes, it must be in all the way. All right, so here we go the other way.
Okay, it's pushing hard on
Yeah,
that.
you got to unlatch here.
Yeah, it's resting on that. Okay. All right,
Okay, so.
go ahead. Something's hanging up here. Okay, there it goes.
reached its limit.
Okay, let's run it back in.
All right.
And we have a latch here, a little bit more, a little bit more. Okay, now I'll try and keep going.
Yeah, stick the latch. Oh yeah,
Keep going, it's gotta go.
it won't go in with the latch. See, there you go.
Okay, hold on, let me clip it. Okay,
Okay.
there we go, all the way in.
All right. So
Keep going, all the way in. Was that it?
It quit.
Okay.
See?
So we do have just a little bit of tension on that on purpose. Now we're going to flip it over and we're going to adhere it to this aluminum, and we're going to test it lifting the panel. All right, we got it flipped over, and now what we're going to do is we're going to adhere the VHB tape to this aluminum.
The aluminum is screwed in place.
Yeah, the aluminum's screwed into this pallet, so we can just sort of see about the stresses, see how well the VHB sticks, all that kind of jazz. And it's windy today, which is good. All right, so we're ready to test it. Now, this is a latch. This functions as a latch. So we're going to go ahead and see here. Mike's going to manually actuate it, and we're going to see.
It took us quite some time to get this latch. All right, so let's...
Oh my God, it did it. Keep going. Oh, that is freaking awesome. Oh, hold on. Something bad's happening.
Yeah.
In the middle, it's bending that aluminum bar down.
Yeah, it's too...
What's happening? What is happening?
It's pushing it. It should be pushing it upward. It's pushing it downward. Okay. So
Reverse.
let's go back. So reverse.
Well, the latch works. Why is it doing that?
Lift it. See?
Okay, so I'm gonna help it.
Oh, it's pushing it down.
Stop,
it needs
stop,
to
stop.
push it up.
Yeah, do it the other way.
We're going the other way. We're going... Yeah, we don't have it.
You want to have the angle right on the
No, the
thing.
angle has to be up higher, right up against the base of the glass. And almost, if we had that angle up, yeah, that angle has to be higher. So it's actually pushing down. What if we
Fail.
here, so it's up higher that way, and let's try to push.
All right, we're gonna try and manually change the position of this somewhat. So go ahead.
Push it, push higher.
Oh, I am pushing as high as it. Oh, no, that's not good.
Okay, it's going the wrong way. The latch works good. Oh,
So we're able to manually help it up, and that's what it looks like. We get not quite a 45-degree.
yeah. I think this
Lift
pivot,
with it.
This pivot needs to be up here. But you were afraid that it would push on the glass. But actually, if you had a wide panel on it, it could kind of push on it as a wide surface. I don't think it's going to hurt it.
Yeah, we got to redo that bar.
Oh, winter sun right there.
All right, down.
Okay, let's go down.
Whoa, crash all at once, huh?
Oh yeah, it did crash, didn't it?
Well, that wasn't expected.
No, that crash wasn't expected, but it latched good.
Why did it do that? Is
Yeah,
it
because it
came around
because that angle is not right.
the angle on that attach point is not right.
That touch point should be. All right.